Have you ever looked up at the night sky and felt like you were at the very center of everything? For thousands of years, that's exactly what humanity believed. We thought the sun, the moon, the planets, and all the stars gracefully danced around our Earth. It was a beautiful, comforting idea. But what if I told you that this entire cosmic ballet was an illusion? That our planet wasn't the star of the show, but just one dancer in a much grander performance? Today, we're diving into one of the most profound shifts in human thought, the heliocentric revolution, the incredible story of how we discovered that the Earth revolves around the sun. This wasn't just a small correction in an astronomy textbook. It was a revolution that shook the foundations of science, religion, and our very understanding of our place in the universe. To truly appreciate this shift, let's travel back in time. For centuries, the geocentric model, championed by the brilliant astronomer Ptolemy in the 2nd century AD, was the undisputed truth. Imagine a system of crystal spheres nested inside each other like Russian dolls. The Earth sat motionless at the center. Around it, the Moon, Mercury, Venus, the Sun, Mars, Jupiter, and Saturn each had their own sphere, and the outermost sphere held all the fixed stars. It was elegant, it was logical, and it matched what we saw with our own eyes every day. The sun rises in the east and sets in the west. This model reigned supreme for over 1,400 years. It made sense, it was endorsed by powerful institutions, and questioning it was almost unthinkable. But even the most perfect-looking theories can have cracks. As astronomers made more precise observations, they noticed some. Well, oddities. Planets didn't always move in perfect circles. Sometimes they seemed to slow down, stop, and even move backward for a little while before continuing on their way. This is called retrograde motion. To explain this, Ptolemy's model had to get incredibly complicated. He added little mini-circles called epicycles, where planets would loop the loop on their main orbits around the Earth. It was like adding gear after gear to a machine to make it work. It got the job done, but it wasn't very elegant. The universe was starting to look less like a divine clock and more like a messy piece of machinery. These growing complications were whispers of doubt, setting the stage for a brave new idea. Enter Nicolaus Copernicus, a Polish astronomer and mathematician living in the 16th century. Copernicus was a deep thinker, and he was bothered by the complexity of the Ptolemaic system. He wondered, what if there's a simpler way? He looked back at ancient Greek texts and found an idea once proposed by an astronomer named Aristarchus of Samos that had been largely forgotten. What if the sun was the center and the Earth was just another planet orbiting it? This idea is called heliocentrism, from the Greek words helios for sun and kentron for center. Copernicus spent decades working on this theory, doing the math and making calculations. He realized that placing the sun at the center elegantly explained retrograde motion without the need for all those complicated epicycles. Imagine you're in a car on the highway and you overtake a slower car. For a moment, from your perspective, the slower car appears to be moving backward, even though you're both moving forward. That's exactly what happens when a faster-moving Earth overtakes a slower-moving outer planet like Mars. It was a brilliantly simple explanation for a complex problem. But Copernicus knew his idea was radical, even dangerous. It directly challenged scientific orthodoxy and the powerful religious doctrines of the time. Because of this, he hesitated to publish his work for years, only sharing it with trusted friends. It was only on his deathbed in 1543 that his groundbreaking book, On the Revolutions of the Heavenly Spheres, was finally published. The revolution had begun, but quietly. For the next few decades, Copernicus's idea remained on the fringes, a curious mathematical alternative but not widely accepted. It took a new generation of stargazers, armed with new technology, to bring the heliocentric model into the light. One of the most important figures was Galileo Galilei. In the early 1600s, Galileo heard about a new invention, the telescope. He didn't invent it, but he significantly improved it and, most importantly, he was one of the first to point it towards the heavens. What he saw changed everything. He discovered that the moon wasn't a perfect, smooth sphere, but was covered in mountains and craters, much like Earth. He saw that the Milky Way was not a celestial cloud, but was made up of countless individual stars. And most damningly for the old model, he discovered 4 moons orbiting Jupiter. Here was a clear-cut case of celestial bodies not orbiting the Earth. If Jupiter could have its own little system of moons, then why couldn't the planets orbit something else like the Sun? He also observed the phases of Venus. Just like our moon, Venus went through a full cycle of phases, from a sliver to a full disk. This was something the Ptolemaic model simply could not explain, but it was perfectly predicted by Copernicus's heliocentric model. Galileo became a passionate advocate for the Copernican system. He wrote and lectured about his findings, but his bold stance put him on a collision course with the powerful Roman Catholic Church. The Church held the geocentric view as dogma, intertwined with religious scripture. In 1633, Galileo was tried by the Inquisition, found vehemently suspect of heresy, and forced to recant his support for the idea that the Earth moves. He was placed under house arrest for the rest of his life. It was a dark moment for science, but the truth couldn't be locked away forever. Galileo's work and his telescope had provided the observational evidence that the revolution desperately needed. The cat was out of the bag. The final pieces of the puzzle were put into place by 2 other giants of science, Johannes Kepler and Isaac Newton. Kepler, a German astronomer and a contemporary of Galileo, was a mathematical genius. He meticulously analyzed years of precise astronomical data, especially for the orbit of Mars. He discovered that Copernicus wasn't entirely right either. The planets didn't move in perfect circles. Instead, Kepler's first law of planetary motion states that they move in ellipses, or ovals, with the Sun at one of the 2 foci. His other laws described how a planet's speed changes as it orbits the Sun, moving faster when it's closer and slower when it's farther away. Kepler's laws provided the precise mathematical description of how the heliocentric system worked. But the big question remained. Why? Why did the planets move this way? What invisible force held them in these elliptical orbits around the Sun? The answer came from Sir Isaac Newton. In 1687, Newton published his Principia Mathematica, arguably the most important scientific book ever written. In it, he laid out his 3 laws of motion and, crucially, his law of universal gravitation. Newton proposed that every object in the universe attracts every other object with a force. This force, gravity, is what keeps the moon orbiting the Earth, and what keeps the Earth and all the other planets locked in their orbits around the massive Sun. Newton provided the physical explanation, the underlying why, for the heliocentric model that Copernicus had proposed and Kepler had refined. The revolution was complete. The shift from a geocentric to a heliocentric universe was so much more than just rearranging the solar system. It was a fundamental change in our perspective. We were no longer the center of creation, the focal point of the cosmos. Instead, we were inhabitants of a small, rocky planet orbiting an average star in a vast, sprawling galaxy, which itself is just one of billions of galaxies in an incomprehensibly large universe. This realization was humbling, but also incredibly liberating. It opened the door to modern science, encouraging us to question, to observe, and to seek evidence-based explanations for the world around us. It taught us that our senses can be deceiving and that the universe is often more strange and wonderful than we can imagine. The legacy of Copernicus, Galileo, Kepler, and Newton is not just the knowledge that the Earth goes around the Sun. It's the spirit of inquiry that drives us to keep looking up, asking questions, and discovering our true place among the stars. Thank you so much for joining me on this journey through one of history's greatest scientific upheavals. If you found this as fascinating as I do, please hit that like button and subscribe for more deep dives into the wonders of science and history. Let me know in the comments what you think. Did this story change your perspective on things? Thanks for watching, and I'll see you in the next video.